Welcome! In this lesson, we will solve three numerical problems using Hess's law. Hess's law says, if you can build a target reaction by adding, reversing, or scaling known reactions, then the standard enthalpy change, delta H naught, for the target is the same combination of the known delta H values. We will follow a clear three-step strategy. Step 1, write the target reaction. Step 2, manipulate the known reactions until the reactants and products match the target. Step 3, add the delta H values, remembering to flip signs when reactions are reversed and to multiply when reactions are scaled. Example 1. Find delta H naught for the reaction. Carbon graphite plus 1/2 oxygen gas produces carbon monoxide gas. We are given two reactions with their enthalpies. Step 1, write the target. Step 2, reverse the second given reaction so that carbon dioxide becomes carbon monoxide plus 1/2 oxygen. Reversing flips the sign of delta H from negative 283 to positive 283 kilojoules. Now add the reversed reaction to the first given reaction. Carbon dioxide cancels, and we obtain the target directly. Step 3, add the delta H values. Negative 393.5 plus positive 283 equals negative 110.5 kilojoules. So delta H naught equals negative 110.5 kilojoules. Example 2. We want delta H naught for 2 nitric oxide gas plus 1/2 oxygen gas produces nitrous trioxide gas. We are given three reactions. A smart route is to first combine reaction 2 and reaction 3 to build 2 moles of nitrous trioxide from nitrogen and oxygen. Add their delta H values to get negative 276.2 kilojoules. Now reverse reaction 1 to move 2 moles of nitric oxide to the reactant side. Reversing flips its sign to negative 181.6 kilojoules. Add the reversed reaction 1 to the combined reaction. Nitrogen cancels. We get 2 nitric oxide plus 2 oxygen equals 2 nitrous trioxide, but the oxygen simplifies to 1/2 oxygen per 1 nitrous trioxide. When we divide the entire reaction by 2, the enthalpy also divides by 2, giving negative 228.9 kilojoules. Example 3. We will use standard enthalpies of formation. The target is the decomposition of calcium carbonate to calcium oxide plus carbon dioxide gas. Recall the formula. Delta H naught of reaction equals the sum of delta H formation of products minus the sum of delta H formation of reactants. Now substitute the values. Add the product enthalpies and subtract the reactant enthalpy. We obtain plus 178.3 kilojoules. That is endothermic. Recap. Hess's law problems follow the same pattern. 1. Write the target reaction. 2. Reverse or multiply known reactions to match the target. 3. Add the delta H values with the same operations to get the final delta H. If you reverse, flip the sign. If you multiply a reaction, multiply its delta H. With practice, the algebra of reactions becomes intuitive.